Okay, thank you very much for the invitation to this exciting conference. It's a packed program and really exciting. So I'm very sorry that I, due to prior engagements, had to miss some of these. So what I'm going to talk about is what historians of science would call the reception of Gregor Mendel, and a question that has occupied Mendel scholars forever and continues to occupy it, namely whether he belonged to an older tradition of hybridism, or whether he was a geneticist, or whether he was something entirely different. Michel Foucault called him a monster. That's something I can take up in the discussion maybe. What is curious about Mendel's achievements is that they were published first in 1866 in a local Naturalists Association journal. It was a well-respected association. It was very local, the Verhandlungen des Naturforschenden Vereines in Brno, as it's called today in the Czech Republic. Mendel, as we know from his printer's copy of his manuscript, sent out off-prints, Separatdrucke, in the top left-hand corner. He ordered 40 off-prints and sent them out to quite well-known biologists, Nägeli and Kerner von Marilaun in Austria, Karl Nägeli, and 6 at least of these have been preserved. So he tried to distribute his results. But as we all know, it took another 34 years for Mendel to be rediscovered, as people like to put it. 3 botanists in parallel, Hugo de Vries, Carl Coggins, and Erich von Tschermak, published in 1900 papers that presented results from their own experiments, but also pointed to Mendel's paper as having preceded them. Now, what is additionally curious about this story is that this idea that Mendel 34 years discovered something spread immediately, almost in no time. In 1901 alone, you have several publications, these are not all, that sort of rehearse, review the results of Mendel, including Bateson in Cambridge, who later should go on to coin the term genetics, including Wilhelm Johannsen, who coins the term gene, but also Davenport, famous for his eugenics, unfortunately, and Castle, a plant breeder in the US. The paper was also immediately edited by Erich von Tschermak, one of the rediscoverers. It was the edition was published in a very well-known series back then of classic papers in the sciences. It was produced by the chemist Wilhelm von Ostwald, mainly for pedagogical reasons, to acquaint students with classic experiments and classic achievements in the science. And Mendel's paper ended up only a year after his rediscovery between Malpighi, the 17th century plant anatomist, and a mathematical paper by Gauss, which is quite nicely placed. This is how the edition of Mendel's paper by Tschermak is set up in the open stacks of Cambridge University library. Unfortunately, a little bit in the wrong order. So you see Malpighi's Anatomie der Pflanzen, Anatomy of Plants, a little bit out of place, but he's in the middle of Malpighi and Gauss. The paper was also translated into English. Bateson commissioned this translation a year after the rediscovery. And ever since then, there have been English editions. Probably the most influential is this inconspicuous pamphlet, which was published by Harvard University Press and ran through the editions until the 1980s, I believe, in this pamphlet form. But there were more scholarly editions also by geneticists. The latest one by Scott Abbott and Daniel Fairbanks, which was published in the journal Genetics, and uses the German translation of Darwin's Origin of Species to produce a translation that is true to the terminology of the time when Mendel published his paper. The reason for this success is can be gleaned from this document. This handwritten notes at the end of Czermak's edition by Nilsson Ehle, a Swedish plant breeder and geneticist, who one can see here practicing Mendel's notation system on the last page of Czermak's edition. He's trying to figure out the logic of dihybrid crosses. He ends up with something that structurally comes close to the Punnett square, which is quite interesting. So Mendel's paper was not only read, it was used to learn the methods of genetics. Now, I have myself, with Kerstin Hall, who will speak in a minute, produced an online edition of Mendel's paper. That edition is not meant to, and translation of Mendel's paper, it's not meant to replace earlier translations. We think that all of these translations have their value and are actually, in a sense, good translations. What we try to do with this translation is provide a window onto the original. So we've designed it in a way that enables you to directly compare sentence by sentence the German original with our translation. And then in the comments, we also discuss earlier translations and problems of translation. So we want to give access to the German original through this translation. It has been, it has appeared in print. It's a nice edition, but we are aware that a print edition has its limitations in comparison to the online edition. Okay, so the big question, as I already mentioned in the Mendel historiography, is, was Mendel a hybridist belonging to an older tradition, or was he a geneticist? And I won't go into much detail about this. What I want to do in the following is propose my own version of why Mendel from 1900 on was so successful. But it's worth pointing out perhaps that by now I think there is a consensus among Mendel scholars that Mendel was clearly embedded in the hybridist tradition. He himself entitled the paper in a way that draws attention to hybrids. He only speaks of a law of development of hybrids. So he was interested in hybrids, and his theory, the theory he tentatively develops of how factors or elements, as he calls them, are transmitted from one generation to the other, is quite different from genetic theories of the early 20th century. He does not assume that these elements or Anlagen or dispositions, that these are discrete particles. He thinks they can merge, and they do merge when it comes to homozygotes, and they are kept separate in the case of hybrids or heterozygotes. So in terms of theory, he's rather the end point of of a long development that reaches back to Linnaeus and Kölreuter in the 18th century, rather than the beginning of something new. So how can one explain his success? One way is, of course, to say this is just myth building and has to do with disciplinary dynamics. You needed a father for the discipline, a father figure, so he was retrospectively identified as a geneticist by geneticists. But what speaks against this is this intense use of his paper by geneticists. I found many annotated copies and analyzed them in an article for the British Journal of History of Science. So it can't be the whole story. And I now want to use our translation to give you some hints towards another explanation of Mendel's success. So this is how our online translation looks. We have the German text and the English text next to each other, and you can navigate you can click individual sentences, and then you are led to pages that look like this, where you have the two sentences and where you can immediately compare one. And what I want to draw attention to here is the expression Detailversuch. Mendel called his experiments Detailversuche. This has been translated as detailed experiments, but it is one word. Germans like to create one concept by putting together lots of nouns, and this is one example. So it's a special kind of experiment, and one can argue that it's a way of experimenting that Mendel engages in, that he learned when he was trained in physics in Vienna from a school of physicists there that was led by the physicist Doppler, and that consisted in constructing whole series of experiments that tested various hypotheses, alternative explanations that used control experiments. So an experiment never stands on its own. It's always an element in a series, a multiplicity of experiments. And of course, also you tabulate all your results, all your quantitative results, your data, and so on. This, I've done a bit of research on this. This is a language, the language of Detailexperiment, that doesn't enter biology, but it enters engineering and chemistry. So these words are used throughout the 19th century in engineering and chemistry. Okay, so the next detail I want you to, so here's an example of one of these publications from the 19th century, in this case from chemistry, where people talk about Detail. Das Detail dieser Resultate ist folgendes. The next detail I want you to draw your attention to is this sentence, also from the introduction. Die vorliegende Abhandlung bespricht die Probe eines solchen Detailversuches. The present treatise reviews a specimen of such a detail experiment. So this has also variously been translated by Bateson as results of such a detailed experiment, by Sherwood as the attempt at such a detailed experiment. But Probe is a very particular word in German. It can mean a variety of things: attempt, test, exemplar, or sample. But it is mostly used for the production of a sample or specimen of work that demonstrated one's mastery of a particular skill. For example, this was common in guilds and universities, that you proved your prowess in a certain craft or in a certain discipline by providing a probe of what you're doing. So Mendel clearly conceived of his experiments as a demonstration of his skills as an experimenter. This now takes us to a third little detail, a sentence in which reveals that Mendel selected the experiments he published in retrospect. He did a lot more experiments than he actually published, and he selected those that were able to demonstrate his experimental prowess the best. Ja, so that's this sentence here. Der Erfolg musste endlich zeigen, ob sie in hybrider Vereinigung sämtlich ein übereinstimmendes Verhalten beobachten und ob daraus auch ein Urteil über jene Merkmale möglich wird, welche eine untergeordnete typische Bedeutung haben. And the translation: in the end, success had to show whether they, and that is the selected characters or character pairs that Mendel focused on, wrinkled, smooth, green, yellow, you all know about this, all follow a concordant behavior in hybrid union, and whether from this a judgment becomes possible about those traits too that have a subordinate typical significance. The decisive detail here is that Mendel speaks in the past tense. This is not captured by Bateson's and Sherwood's translation. Bateson says they must show, so because these are the laws of nature, presumably, and Sherwood says should show. Renders Mendel as expressing a hope rather than something accomplished. But the German originally is without doubt formulated in the past tense. And it clearly indicates that Mendel selected the character pairs he wanted to focus on in his presentation in retrospect, after he had successfully performed his experiments. So he chose those character pairs that did segregate, that showed a 3-to-1 ratio in the first generation of hybrids, as Mendel called it. Okay, so this is a schematic representation of Mendel's experiments, and it becomes really obvious if you present it like this, how reduced these experiments actually were. How, if you compare this with what Mendel's predecessors did, people like Kohlreuter or Gärtner, they always crossed varieties and species that differed by many characters. And they crossed as many different species as possible. In Gärtner's case, several hundred. He worked with several hundred species or varieties. Mendel reduces this to 2 clearly marked varieties. He calls them species, but we would nowadays call them varieties. He carries out 1 cross. He artificially pollinates the plant, one variety by the other, with the pollen of the other. That's the experimental intervention. And then the plants are left to themselves. They are actually self-fertilizing. He has to take care a little bit about insects that cross-pollinate and so on, but he mentions all of this. He leaves them to themselves, to self-fertilization, and observes the result in succeeding generations. So this is a highly constructive way and targeted way of doing experiments on hybrids. And that's what he wants to show off as a method that can produce results that are consistent over a large number of experiments, and that follow a certain pattern, a pattern that indicates that the Elemente or Anlagen or genes, as we would say today, are transmitted in this case, in the case of the character pairs he worked with, without interacting with each other, and are distributed randomly onto the gametes in gamete formation. So in a way, this brings me to an important interpretation of Mendel's experiments by R.A. Fisher, because I believe that he, in his classic paper, Has Mendel's Work Been Rediscovered, gets it right. That paper is very well known because it conclusively shows that some data of Mendel were too good to be true. But Fischer also doesn't see a problem in that, because to him, what Mendel was trying to do was really to demonstrate the fruitfulness, the applicability of his methods. And Mendel was, according to Fischer, not necessarily in the business of providing a theory. Mendel does, of course, at the end of his paper, speculate a little bit about a theory. But the main thing, according to Fischer, about Mendel's paper was the method. And the theory changed.
Stefan, sorry, Stefan,
yeah.
We lost you a bit. So can you just highlight what's really important for Fischer? Thank you.
Sorry. I'm sorry for that. Well, for Fischer, Fischer presents a reading and interpretation of Mendel according to which Mendel...
Actually, connection here is really poor. So I will ask people in the room, please just not using Wi-Fi at the moment during the talk, okay? So just try to keep the talk as smooth as possible. So sorry, Stefan, yeah, please carry
on. Third go. Fischer presents this interpretation that Mendel's aim in his paper was to demonstrate the power of his experimental system as a tool of analysis, and that is what was important about, and that the subsequent theoretical debates within genetics have produced one interpretation of Mendel after the other, depending on the different theoretical viewpoints of the geneticists. And I think there's a lot in Mendel's paper, as I hope to have been able to show, that supports this theory. In a way, Mendel, one can overstate this maybe a little bit, but in a way, Mendel invents the work with model organisms and experimental systems, a way of working that comes to dominate the 20th century life sciences. And that's, I think, what was picked up in 1900 with his discovery and spread rapidly among biologists, and not a certain theory that he might have come up with. Okay, thank you very much. I stopped sharing my slides and hope that I didn't take too long. Thank you.